I hear. Okay, great, great. That's already a big success. So that was actually the goal. So we are finished here. No, I'm joking. It's a pleasure to be here with you today, and I would like to go through a short presentation on well, artificial intelligence, the history, what's happened, and what's next. So to begin with, I don't know whether you know Shawise. That's one today probably one of the most advanced AI in the world, and apart having daily conversation with millions of people in China, she's probably one of the most followed poetess in the world, as she has more than 660 million followers on our media. And today, with the AI, you can take a picture and using one of the main programs that based on machine learning, choose a painting style and create something like this one, like this picture. And doing a little bit step further, today in Netherlands, we show to an AI algorithm an high number of painting from Rembrandt, and then that algorithm based on the painting that he saw and using an advanced 3D printing solution. But that's not really the interesting thing. That algorithm was able to create a new masterpiece that the best expert in the world from Netherlands admitted they would have thought it to be this one, an original masterpiece of Rembrandt, never seen before. Then I honestly have no idea about what happened to that painting. And today, really, the news that you heard while I was trying to make this conversation on LinkedIn Live starting, it's also being composed by artificial intelligence. So today, music, poetry, painting, maybe art, I don't know. Let's see. And anyway, since we talk about AI from a long time, actually, you may consider that a computer able to calculate 200 million movement per second was able to win against the human world champion at chess. That computer was called Deep Blue. That player was called Kasparov. But that year was 1997. Think about it. It was 23 years ago. It was really a prehistoric computer compared to what you can do today. It's really amazing. It was 23 years ago. And really, the growth of AI began in the last years when the friends from Google created AlphaGo, an algorithm that was able to win against the human world champion in a game which is several trillions times more complex than chess from a computational point of view. What has been done here has been teaching to the algorithm the rule of the game, and then the algorithm played for 3 hours against itself, and it learned how to win against the human world champion. And soon after, AI reached human parity in the ability to recognize objects when there is proper training. So in cognitive services, in visual cognitive services. And soon after, it reached human parity in voice recognition. And so in the test that Switchboard is based. And a little bit more than 1 year ago, AI reached human parity in the Stanford question and answering, which is really advanced and requires some profound understanding of the text from AI. And recently, last year, AI reached human parity in the ability to translate from Chinese to Western languages. So you can use this technology to read Sunshine, which is the last book written by Xiao in China. And this means that basically today, AI is used more and more everywhere. It's a little bit like electricity. And if you think that electricity is really a general purpose technology, which means that it can be used everywhere, that's true also for AI. It will be used everywhere. And continuing on the same comparison, when AI was introduced, it was used to do the same thing in a little bit but more automated way. So we used to have a steam engine, and that steam engine was replaced with an electrical engine. But then the real magic started when later on, Ford and Taylor realized, and many other after them, that with AI, you could really transform the factory. You could put the engines in different place of the factory. And this is what's also happening with AI. At the beginning, companies are using it to automate. Then it becomes more and more interesting when companies and us as a society realize that with AI, we cannot really only automate, but we can adapt, we can create the future. And clearly there is a big challenge here in terms of timing, when some jobs, some skill may disappear to the automation, and many new ones will be required and needed due to the future we are creating. And there is also a very big reskilling challenge behind the slide, because you may realize, you may really think easily how different are the skills that will be needed in the future with AI from the skills that were used to be required in the past. And to begin with, AI is used today to change the way we are conversing with machine. We are moving from a world where we had to understand computers to a new world where computers are able to understand us more and more. And really, if you talk with any technology company, you will have this picture where everything started with web, then with the apps, but the apps world is probably gone. It will soon be a legacy somehow, because we will have an AI talking with us, conversating with us, and then this AI will talk with the artificial intelligence in our car, in our office, in our home, with domotic, everywhere, with ambient artificial intelligence. Also, we are amplifying our ability to perceive the world. We are giving machine and to us increased ability to perceive the world around us. And this means that we can use AI in a huge amount of scenarios. For instance, in workplace safety, using AI with an algorithm, with a telecamera, to understand whether there is some object that may be dangerous in the middle of the factory on the working floor. We can use it everywhere in healthcare, which is so important also today for the big pandemic we are facing worldwide. And clearly in healthcare, it's really, really a big application area. This is an example in Cambridge of AI used to analyze exams that are relevant for oncology, for pneumonia, and many other cases. And we can also already have a big inclusivity reason for AI to help us. For instance, in this project, AI has been used by a colleague in England, Shaktir, to create an application that enables him to see the world somehow, even if he's not able to see from birth. And actually, this algorithm also tells him when he's talking, whether there is someone smiling, someone annoyed, someone sad. And you can imagine easily how much this will change completely the ability to him to change the world, really, to live the world in a different way, to completely improve his social experiences. Then, actually, the area where there is the biggest impact from artificial intelligence is augmenting our intelligence at the end. I will not cover so much this in this first webinar, in this first conversation, because this will be subject to many other things that I will hope to share with you also based on the feedback that I will really be happy to receive from you in terms of what you would like to cover in the next conversation we will have. Clearly, everything that I presented so far in these few minutes is old. If you think about it, everything that I shared in these few minutes belongs to the past, from 1993, 1997 to the last year. But there is nothing related to the future yet. And in the near future, actually, everything will get even more exponential. And to understand this, we need really to comprehend why AI is happening today. We talk about artificial intelligence since a while, but artificial intelligence is growing really right now, only in the last years, because only now we have the computing power, the amount of data, and the kind of algorithms that are needed to really boost artificial intelligence and machine learning, deep neural network at large. So let's see each one of them a little bit to understand what's next, what's coming into the near future. And at the beginning, AI was used to be run on CPU, the one that are using normal computer. Then we realized that GPU, graphical processing unit, are really powerful to elaborate AI algorithms. But today, FPGA, field programmable gate array, are really the medium, the hard code, which is used to process the most advanced AI algorithms, because it's able to adapt at electronic level. And this means that with FPGA, you can translate the entire Wikipedia in less than the blink of an eye. This is about computing. Then that also means that with this new chipset, the hardware is now 500 times smaller than a blood molecule. And this means we are really near quantum computing. Quantum computing is the next step. There are already prototypes working. With quantum computing, the scientific community expects that we will be able to elaborate in minutes or in seconds what today is required to be run in more than the lifetime of the universe. So there are huge implications on quantum computing. I will not cover it in these few minutes, but it's something really important. And the data are the other thing that are really transforming our world. They are increasing exponentially, as you have probably heard in many occasions. And this means that we need a new way of processing data, storing them, and very promising is the usage of synthetic DNA, which means that we can use synthetic DNA to store information. Many research organizations are working on it. And with synthetic DNA, it is expected you will be able to store in a cubic inch more than what it is stored in some of the largest data centers in the world. And also with synthetic DNA, you could have a resilience of the data of more than 1,000 years. And finally, we will always be able to read synthetic DNA because we are made by DNA. All of this, so this very big data run on this extremely powerful computing device is required and to be processed on neural network, and neural network are really becoming more and more deep and advanced with new kind of algorithms. So entering the last part of this conversation, and then I would like to check on LinkedIn and all the other social media if there are questions to answer to make this even more conversational. Which future are we creating with all of this? This is the big question, obviously. And I understand that with quantum computing, synthetic DNA, and so forth, there are concerns. There may be concern, and someone may think about a picture like this, or actually, this is the real picture, where actually that's a concern. Because if I have to be honest, I'm more concerned actually not by artificial intelligence, but by its opposite, which is natural stupidity. And if you ask me in which kind of society will live my little Elisa, I have no idea, because what I showed you are just technology trend. And the truth is that the best way to predict the future is to create it. And it's up to us at the end. Because until for a long time, we will be the one building algorithms, hopefully many times in the right way, and sometimes I hope learning from our mistakes. For a long time, we will be the one deciding when to use this algorithm and when not to use them. And for a long time, we will be the one training algorithms. And algorithms, as we know, learn from us, which means that in most cases, for instance, if I had to build an AI algorithm in any company or in most of companies, learning from the data which person to hire to promote, the algorithm may learn to hire or promote white male, because that's not a fault of the algorithm, it's what it may find in the data. Then in many companies today, unfortunately, the board, the manager, are mainly composed by males and maybe white people, at least in the Western world. But that's where we have a big opportunity to coach the algorithms, taking away all of these biases. And the good thing is that once we do it, the algorithm really learn it, and there is no bias any longer. So we have a big opportunity as a society, but it's up to us again. And also we are moving more and more towards, but this is, sorry, LinkedIn, can you see?
Yes, this is LinkedIn.
Okay, great. I'm just checking because it's the first time we use it. And
at the beginning here. Okay.
And actually, so we are moving more and more into paradigm where we see collaboration between us and the machine. And I start with chess, but today the most advanced chess player in the world, if they play using an algorithm, they win against the human one champions, but they win also against the algorithm itself. And to conclude this short conversation, this short presentation, as AI advances in its capabilities, what will matter most actually will be our values, our heart, our empathy, our values, because it's based on this that we will build, we will train, we will decide what to use and what to do with this technology. Really, not to predict the future, but to create it indeed. And quoting what Ben Parker was to say to his nephew, Peter Parker, it's clear that this technology will give us a very powerful capability, but with a great power comes a great responsibility. And in this case, the big responsibility is really how to use this technology to create the future. So I hope you found this conversation interesting. It's really the first time I use LinkedIn and these other streaming media on social networks. So I hope it was somehow working. I probably have a lot to learn on this. So I really look forward to any feedback, any learning, any recommendation. I know it has been a little bit of a presentation, and probably in many other cases, I will try to make it even more conversational. Actually, I'm now checking on okay, I don't know whether it worked or not, but anyway, let's see how it worked, because it's the first time, so I don't know. I hope it was fine, and for looking forward to talking again with you in other scenarios. Thank you again. Bye. Ciao.